A strong relationship between solar cycle length and temperature is seen in other data sets. This is a figure from a 1996 paper by Butler and Johnson of the Amar Observatory. The slope of the line is half a degree centigrade per 1 year change in solar cycle length, which amounts to 1.4 thousandths of a degree per day. Now let's assume that the relationship demonstrated in nearly 200 years of Amar data and 300 years of de Boult data is valid today. I have plotted on the top of this original figure solar cycle 22, which was 9.6 years long. Solar cycle 23 hasn't finished yet. If it was an average cycle length of 10.7 years, it would have finished in January 2007. It is now mid-2007. As we haven't seen the first sunspot from solar cycle 24 yet, solar cycle 23 will be at least 12 years long. If it is 12 years long, it follows that the temperature at Amar will be 1.2 degrees lower. If solar cycle 24 is as weak as a number of solar physicists are predicting, then solar cycle 23 is likely to be 13 years long or longer. Solar cycle 4, preceding the Dalton minimum, was 13.6 years long. I have plotted on this figure what a 13-year long solar cycle 23 would look like. It would result in a 1.6 degree decline in temperature. Now this effect is upon us right now. In a few short years we will have a reversal of the warming of the 20th century. Now this graph demonstrates the transition of one sunspot cycle to the next, using the example of the solar cycle 22 to solar cycle 23 transition. Now what we see is you get sunspots at lower latitudes in the previous cycle continue to die off, and at higher latitudes, above 20 degrees latitude, a year before, 20 months before, or even longer, you start getting the first sunspots of the next cycle. Then they overlap. The overlap is minimum, is considered to be solar cycle minimum. Solar cycle 23 started in May 1996, rising to a peak of 120.9 in April 2000. For solar cycle 23 to be of average length, solar cycle 24 should have started in January 2007. The first sunspots of a new solar cycle appear usually at more than 20 degrees latitude on the sun's surface. According to the last couple of solar cycles, the first sunspots appear 12 to 20 months prior to the start of the new cycle. Now, apart from a few spotless magnetic dipoles, there have not been any reverse polarity sunspots with a latitude of more than 20 degrees to the date of this presentation. This means that solar cycle 24 is at least 1 year away, or the observational rule is wrong. Large solar cycles usually arrive early and small solar cycles late. If the observational rule regarding the relationship between the first sunspot of the new solar cycle and timing of solar cycle minimum holds, then solar cycle 23 will be at least 12 years long. It also follows that the longer the delay till the month of solar minimum, the weaker the amplitude of solar cycle 24 is likely to be. I said at the beginning of this presentation that you can check up on my prediction of imminent cooling every day. And you can do that thanks to amateur radio enthusiasts. They need an active sun with a lot of solar wind to get long distance propagation. A good amateur radio website is solarcycle24.com. It updates every 6 minutes. By my calculations, every day's delay in the onset of solar cycle 24 will lower the average temperature over that cycle by 1.4 thousandths of a degree centigrade. We have already been delayed by a year, so that will translate to a 0.5 degree centigrade decline. Also, by my calculations, A 1 ppm increase in atmospheric carbon dioxide increases temperature by 1,000th of a degree. So it only takes 2 days delay in the onset of solar cycle 24 to offset the increased temperature due to 1 year's emissions of carbon dioxide. Every day's delay until the first sunspots of solar cycle 24 mean that the Earth's climate will be harsher in the second decade of the 21st century. This graph shows the progression of the last 5 cycles. Solar cycles rise much faster than they fall. Longer cycles are weaker, and solar cycle 20, which is the green line, is longer than the others. This is the solar cycle that caused the 1970s cooling scare. Now this graph is another pointer that we're heading back to the weak solar cycles of the 19th century, with 19th century type winters to accompany them. Solar cycles 10 to 15, from 1860 to 1917, had an average of 66 months from the first spotless day, that is a day without any sunspots on the sun's surface, to solar cycle minimum. This was a time of considerable glacial advance in the European Alps. Since then, solar cycles have averaged half that, at 33 months, from first spotless day to solar cycle minimum. So far, solar cycle 24 is plotting on the 19th century line. That's where we were up to a couple of months ago. With the first spotless day on the 27th of January 2004, and if the 66-month observation rule holds, then solar minimum will be on or about July 2009. This would make solar cycle 23 13 years long. Next slide, please, Ray. NASA are supposed to know about solar cycles. They have hedged their bets by making 2 predictions about the amplitude of solar cycle 24, straddling the solar cycle 23 result. Solar cycle 23 had an amplitude of 120. NASA's solar cycle 24 predictions are 140 and 90. I have included this graph because it has NASA stating that the expected signatures of solar cycle minimum have not been seen yet. NASA's solar minimum prediction was wrong when they made it, because to have solar minimum in March 2008 would have required the first sunspot from solar cycle 24 to have been seen by March 2007. Now this is a very significant graph. There are currently more than 24 published predictions of the amplitude of solar cycle 24. I have chosen 7 of these to illustrate the current range of predictions. All of these predictions are by well-regarded researchers. The significance comes from the fact that the highest prediction will result in a temperature some 2 degrees higher than the temperature from the lowest prediction. If the lowest prediction is borne out, this will have a large and negative effect on Canadian grain production, for example, and on all high latitude agricultural production. The experience of the Dalton minimum was that winters were longer and harder, and this effect is with us now.